3, 2, 1. Engine full power.
Welcome to your space journey, where we venture into the future of space exploration. Your journey begins now.
Welcome to your space journey. Today we're diving into something really exciting, a genuinely groundbreaking discovery from the James Webb Space Telescope.
It really is something special.
Yeah, this isn't just, another faint dot. Webb has managed to capture its very first direct image of a brand new exoplanet, TWA-7b they're calling it.
That's the one. And the implications are pretty significant. This isn't just confirming something we suspected. It's a totally fresh find via direct imaging for Webb.
And I heard this single discovery actually boosted our power to find planets this way, like tenfold, is that right?
That's the estimate, yeah. It dramatically expands the possibilities for direct imaging. And there's more, it seems. We've caught this planet, TWA-7b, sort of red-handed, actually shaping its own environment.
Wow, okay.
Right?
So let's get into it. Tell us about this new world, TWA-7b. What are we looking at?
Okay, so location-wise, it's relatively nearby, about 100, maybe 111 light years away. The really astonishing thing is its size, or rather its mass. It's a gas giant, but only about the mass of Saturn.
Saturn's mass? That doesn't sound that small for a gas giant.
But compared to other planets we've directly imaged, it's tiny. It makes TWA-7b the lightest exoplanet ever seen this way. By far, actually. About 10 times lighter than any previous one.
10 times lighter. Okay, that is a leap. And its temperature?
Pretty mild, considering estimated around 120 degrees Fahrenheit or 47 Celsius.
So 10 times lighter. How confident are we? Seeing something that faint directly sounds, well, tough.
The evidence stacks up really well. TWA-7b orbits a star called TWA-7, and this star is young, really young, just 6.4 million years old.
Whoa! Compared to our sun's 4.5 billion years, that's barely an infant.
Exactly, and because it's so young, it's still surrounded by this huge disk of gas and dust, the leftovers from its formation, where planets are being born. We call it a debris disk.
Right, the planet-forming stuff.
And crucially, our viewing angle from Earth is perfect. We're looking almost straight down on the system, a pull-on view, so we see its 3 rings clearly. It's like having a front-row seat to a planetary construction zone.
Okay, that makes sense. A clear view helps. But still, imaging a faint planet next to its bright star. How did Webb pull that off? What's the tech involved?
Yeah, that's the real challenge. It's incredibly hard because the planet is faint, doesn't produce much heat itself yet, and it's completely swamped by the light of its star.
Like trying to see a firefly next to a searchlight.
Precisely. So Webb uses its MIRI instrument, the mid-infrared instrument, and MIRI has this special attachment called a coronagraph.
A coronagraph. What does that do?
Think of it like creating a tiny artificial eclipse right inside the telescope. It has a mask that physically blocks out the overwhelming light from the star.
Ah, okay, so it dims the star.
Exactly. It masks the star's glare, allowing Webb's super-sensitive infrared detectors to pick up the faint heat signature from the much dimmer planet hiding nearby.
Clever. And you mentioned catching it red-handed, shaping its environment. How did they figure that part out?
Right, so TWA-7b showed up as this faint infrared spot. And interestingly, it was located in an apparently empty part of the star's second debris ring.
An empty patch.
Exactly. So the scientists ran simulations, and they found the planet's position perfectly matches where you'd expect a planet to be if it was carving out a gap in that dusty ring through its gravity.
So it's literally sweeping his path clean.
That's the idea. It's the first time we've directly seen a planet and linked it observationally to shaping a gap in its home disk like this. It tells us a lot about how planetary systems actually form and evolve.
That's fascinating. But, okay, TWA-7b is a gas giant, like Saturn. It's not exactly Earth 2.0. So why is finding this planet such a big deal for the search for life elsewhere?
That's a really important point. While TWA-7b itself isn't habitable in the way we think of it, the ability of Webb to spot such a relatively low-mass world directly is huge. It demonstrates a capability we weren't sure we had quite yet.
It proves the tech can see smaller things than before.
Precisely. It pushes the boundaries. If Webb can see a Saturn-mass planet directly, it dramatically improves the odds and techniques for potentially finding smaller, maybe even rocky planets using similar methods down the line.
So it's a stepping stone.
It's a crucial stepping stone. And by studying all sorts of planetary systems, young ones, old ones, ones with gas giants, maybe ones with smaller planets later, we piece together the big picture. How common are systems like ours? Is life rare or common? This discovery helps us refine those questions.
Makes sense. But I guess getting a direct picture of an Earth-like planet way out there is still maybe a bridge too far even for Webb.
You're spot on there. Webb is incredible, pushing limits, but directly imaging a small, rocky planet like Earth in the habitable zone of a distant star. That's probably going to require the next generation of even more powerful telescopes.
Like the extremely large telescope.
Exactly, like the ELT, which is scheduled to come online around 2028. But discoveries like TWA-7b with Webb are absolutely paving the way, showing it's possible and refining the techniques those future telescopes will use.
So this TWA-7b discovery, it's really shown us what Webb can do at the cutting edge, pushing our ability to see these distant worlds and learn how they form. It feels like another exciting step towards figuring out our place in the cosmos, and maybe, just maybe, answering that huge question about life beyond Earth.
Absolutely, it's a fantastic result.
It really makes you wonder, what's the next big surprise Webb has in store for us? What else will it uncover that shifts our understanding? Something to think about. Thank you for joining us on your space journey.
Your space journey.